to lecture number 2. Today I'm going to be looking at formwork. Formwork is that process that we go through for concreting where we prepare the shape. We set up a perimeter, a 3D hollow mold that is going to hold the concrete. That's what formwork is. We're going to go through some of the details associated with that. Specifically, we're going to define formwork for you so you understand what it is. We're going to very briefly talk about form release agents, and then we're going to talk about how formwork is used to achieve a few different slab types, waffle pods, strip footing, etc. You're going to understand at the end of this how to prepare the formwork replacement and to use it in simple concrete projects. And then again, after having learnt this, you can go back and update your JSA documentation for our concreting project to schedule the formwork activities in greater detail. Remember, when we're doing our JSA documentation, we don't want basic steps included like form up the slab. I want you to be really specific about the processes that you undertake for preparing the formwork of the slab. So to get started, formwork essentially is the frame or the mold that holds the wet concrete until it cures. Now you can see on the screen there's a bit of a footpath sort of process that's happening there. It's quite thick. You can see there's some metal reinforcement mesh in there. You can see there's the timber edging, some bracing around the sides. Formwork looks different depending on the type of slab that you are using and the application required. What you've got to remember is concrete mix when wet and when dry is very heavy. And so the higher or the thicker your slab, the more likely you are going to need reinforcement around the edges. Okay, you can see this one's got braces, okay, helping to manage the weight when this concrete is placed in the slab. Now the concrete is placed inside this using either wheelbarrow or the truck. It's compacted using the vibration method to get rid of the air particles, and so that the concrete should be flush up against these timber edges, okay, that have been placed there. Now the formwork that we use for basic slabs is temporary. We get rid of it at the end of the process. But there is permanent formwork that is used in more commercial applications, but we're not really looking at that for our purposes. Once the concrete is finished and fully cured, we can then take the formwork off, and hopefully during that process we have a nice smooth edge on the side of the slab, and then we can backfill the loose land. Okay, all this land can be backfilled in to be a consistent level around the slabs or the footpaths that we place. When we think about the formwork materials, there are a few different things you need to think about. There is the edging process, the form board. That's this piece just here. Now, there are a few different materials that are used here. Plywood is very commonly used. There's a specific product called form ply that is also used. Form ply has a form release coating on it so that it can be used multiple times without damaging the concrete or without damaging the plywood, so it has a longer lifespan. We'll be practicing some slabs with plywood, some slabs with form ply, just to see the difference in the edge finishes. You can use metal stripping as well. This is quite often used in the really commercial applications with with large building companies. But when we're talking about the family handyman, or we're talking about someone that's doing a very basic slab for a basic project, plywood is totally suitable here, as is just some straight lengths of lumber. Plastics are often used as well, and in architectural processes where we're looking at really odd shapes that can't really be formed up with timber, fabrics are also used as well. So if you have a look at the additional link I've got down the bottom here, you can see some of those different edging types and the advantages and disadvantages of them. We then have the supports. So for us, it's typically a stake, okay? So a peg or a stake, as they're called, which is what the formwork is being rested up against, secured to maintain in its appropriate position. Where the form board has significant height and the weight of the concrete is more than the stake is going to be able to handle, the additional kicker and secondary stake is used to give that extra support, the bracing mechanism to help stabilize the formwork under the weight of the concrete. And then in addition to that, we also use a moisture barrier, or what's called a plastic membrane. Now, there are specific Australian standards around the plastic membrane. You have to use a 0.2 millimeter nominal thickness plastic membrane. sorry, 2 millimeter nominal, 0.2 millimeters, correct. Sorry, nominal thickness. There is some stamping that goes across it, really specific in the National Construction Code. Then we'll go across that in a moment, but you need to make sure you comply with that. To help prevent the concrete, the liquid concrete when it dries from sticking to the formwork edge, so sticking to the plywood, the use of form release agents is pretty common. In summary, this is a product that gets put onto the mold to prevent the concrete from sticking to it when it cures. There are different processes that different builders use. A form release agent is a chemical, and so there's the handling process you need to consider when using it. But I've seen in some handyman jobs where people are using things like vegetable oils or whatever, just to lubricate the material to stop the concrete from sticking. Okay, so that's one of the processes that's quite often used. In a standard slab, like if we're talking a footpath outside, the use of a form release agent probably isn't too required, because the edging of the slab isn't on display, so it doesn't need to be a neat finish. As long as it doesn't chip and crack away, a rough edge is totally suitable there. Now, there are a couple of different types of slabs. Okay? When we're talking about the slabs that we do, the basic formwork slabs, we talk about on-grade slabs. These are slabs that are placed directly in contact with the ground. Okay? They're not raised up, they're not beams. We're not talking about building bridge slabs or anything like that. We're talking about just placing a slab on the ground, for example, for a garden shed out the back or for a footpath. There are three different types of these slabs. The first is the slab on ground, which is the method we're going to be following. You've also got a stiffened raft slab, and you've got a waffle pod slab. Now, the main difference is a slab on ground has these nice edge beams around the edges to help give strength to the slab. Underneath directly is the ground, but it's completely flat through the center of the concrete slab, nice consistent thickness through the center. It's only at the edges where we have that thicker edge beam. It's a really basic slab on ground. That's the method we're going to be following. A stiffened raft slab, however, has the edge beams, both sides. It's got a nice consistently thick center, but it also has additional beams going through the center. We call these the rafts. They add additional strength to the slab so that you might use it particularly if you've got heavy weights in the center of the slab, like a load-bearing wall, for example. Okay, so if you've got a center wall in a house that's holding up the center of your roof, then you might actually need a stiffened raft slab to make sure you've got that strengthened beam in the center of the slab where that load-bearing wall is going to be placed. Takes a little bit of extra formwork, but you can see the ground directly underneath it, and there's a little bit of a sand bed in there to fill that different height. Okay. Moving down to the waffle pod slab, this is sort of an extension of the stiffened raft slab. You've got your ribs or your beams running across and down, so you have a grid-like structure. And in the spaces in between, they quite often use styrofoam. Styrofoam helps to firstly insulate it. Secondly, it helps to fill the gap so that you don't have to go in and compact these little square sections of sand or road base underneath your slab. They just simply fill it with styrofoam, they place the formwork around it, and they pour their slab. Okay. Additional strength is used in the waffle pod slab. Okay. They usually use less concrete and less steel than a raft slab, making them cheaper and easier to install because those pods, those waffle pods, are just using polystyrene blocks or void forms to help it. Now, these are useful on really flat ground, but if the ground is not really flat and is quite often reactive or moving quite a lot, you wouldn't really want to be using it. The stiffened raft slabs are quite good with some moisture and movement occurring because they've got a nice supporting base. And sorry, I'll go back here. The slab on ground is usually good for some slight movement from moisture, but pretty stable ground that's mostly made of sand and rock. Okay, three different types. Our focus is on the slab on ground. Now, these are the three types of on-grade slab. Like I said, there are heaps of different types of slabs. Okay? We're focusing on those basic on-ground slabs, specifically slab on ground. What I do need you to be able to do though, regardless of what type of slab it is you need to be able to read and interpret the different types of drawings that we get for the creation of formwork. Now, this is a detailed elevation section of a slab, and particularly the edge of a slab. This is taken directly from the National Construction Code. So if you download a copy of that, go to volume 2, page 115, you'll see this. This shows you in detail, you've got the vapor barrier. Okay, that's that plastic sheeting I spoke about. It goes right along the base of the slab and right up here to where the finished ground level is. Okay, goes all the way around. That stops the moisture from the ground from going up into the slab and then seeping through into the internals of the house. Now, you don't need a vapor barrier or a damp-proof membrane if you're doing a footpath outside, but if you're building on top of it and you want to prevent the moisture from getting into the house, which you definitely do, then that's where that damp-proof membrane is required. You additionally have, over on the side, you can see your framing. Okay, so you can see your bricks here. You can see your internal, your veneered wall. Okay, sorry, go back. This here is a concrete slab, okay, in the center. Usually concrete is depicted with the different dots in the texture. Okay, in this particular application, it hasn't. And then you can see the finished ground, including paving. They've used the appropriate texture there per the standards. So usually they'll be identified using arrows to point out different paths, but you also need to be able to read and interpret the different things. So this is obviously the edge beam. This is obviously the main part of the slab. This here is a rebate where the external bricks sit slightly lower so that any moisture from the bricks doesn't roll into the house. It rolls down here and then is forced outside by this waterproofing process as well. Here's another example of a detailed elevation section. Okay, in this particular one here, we're looking at a stiffened raft slab that's being used with a footing slab. This particular one has even further details. Okay, again, taken from the National Construction Code, Volume 2, page 124. You see the details down the bottom there. What we're seeing here is we're seeing our walls. We're seeing the edge beam, but we're also seeing, if you have a look very closely, see that line and dot process there? That is the symbol used in the detailed drawings for the wire mesh that is used, the reinforcement bars that are placed. Now, you can see those are there. There's specific spacing requirements that show you where non-load bearing walls and where load bearing walls are allowed to be placed. You can see the forces that are being associated. They're indicated using arrows. You can see additional reinforcement bar across the top as well as the bottom of these beams in this type of slab. So there's quite a lot of detail included here, and what you need to be able to do is understand the difference between your regular bits of timber, your end grain of your timber, your masonry, your beams, your reinforcements, and understanding how those drawings look. Now, I've got a video here. I'm not going to watch it live in this lecture. I'm going to share this link with you and ask you to watch it. But this shows you the process of preparing simple formwork, how to calculate how much formwork you need, and explaining how we place the formwork to be ready to then put the reinforcement in and start the concrete placing process. So that's the end of today's lecture. Go ahead, watch this video and answer the questions we've put down for you. And thanks very much, and I look forward to seeing you again next lecture. Thank you.